Welcome everyone, and thank you so much for joining us today. I'm Jane Lewis, a Marketing Manager at Perficient, and I'm excited to be moderating today's webinar, Accelerate Sitecore DevOps on Microsoft Azure. We are recording today, and we will be sure to email you with information on how to access this recording after the session. Time permitting, we will answer questions at the end of the presentation, so please type those into the chat box. In a moment, I'll hand it over to our speakers, but first let me give you a quick overview of Perficient. Perficient is the leading digital transformation consulting firm serving Global 2000 and enterprise customers throughout North America. With unparalleled information technology, management consulting, and creative capabilities, Perficient and its Perficient Digital Agency deliver vision, execution, and value with outstanding digital experience, business optimization, and industry solutions. We have a broad network of locations across the U.S., as well as offshore facilities in India and China. We deliver digital experience, business optimization, and industry solutions that cultivate and captivate customers, drive efficiency and productivity, integrate business processes, improve productivity, reduce costs, and create a more agile enterprise. Founded in 1997, we're a public company with more than 3,000 employees. We formed strategic partnerships with each of the major technology vendors and also have dedicated solution and industry practices. Perficient has a deep expertise in both Sitecore and Microsoft Azure. We have 75 certified Sitecore developers on staff, including 6 MVPs. We're one of only 20 Sitecore Platinum implementation partners. Additionally, we have more than 50 certified Azure consultants, and we were named the Microsoft National Solution Provider Partner of the Year in all regions in 2016, including Cloud Partner of the Year in the East region. And now just a little bit of background on our speakers. Tim McCarthy is a Senior Solutions Architect in Perficient's Microsoft practice. He has been with Perficient for over 6 years and has close to 20 years of experience overall in designing and building web, desktop, mobile, and cloud applications utilizing the latest Microsoft platforms and technologies. As a former Microsoft MVP in Solutions Architecture, his expertise covers a wide range of Microsoft technologies. Tim has spoken at technical conferences around the world and has been a regular speaker at the SharePoint Saturday Conference in both San Diego and Los Angeles. George Chang is a Senior Solutions Architect in Perficient Sitecore practice. He has been named a Sitecore MVP for 2017, and he was named one of only 3 Sitecore Cloud MVPs in the United States. He has been with Perficient for 10 years and has expertise on the Microsoft technology stack and web technologies. With a background in ASP.NET and Microsoft Collaboration Solutions, George has focused the past several years on Sitecore, Enterprise Search, and Microsoft Azure to help organizations make the most of their web presence and keep them on the cutting edge of new technologies. And now I'll hand it over to Tim and George. Tim?
Thanks a lot, Jane. I appreciate it. Wow, that was an awesome introduction. I feel very humbled by it. That's awesome. So anyway, I'm going to tell you what we're going to talk about. So obviously the main focus of this is DevOps, but then we're going to kind of look at the definition of DevOps. I know it's a huge buzzword. Everybody says it. And then we're going to talk about infrastructure as code, specifically on Azure. And then I'm going to hand it over to George, and George is going to talk about how we use Visual Studio Team Services to enable our CI and CD. All right, so here's the big buzzword. You've probably seen this before if you've seen any Microsoft slide decks or if you've been to any Microsoft conferences, but I had to put this in because I really I have a lot of respect for Donald Brown, and he's who I learned a lot about how to do DevOps with Visual Studio Team Services. And his definition, I thought, was probably one of the best ones out there. He says, DevOps is a union of people, process, and products to enable continuous delivery of value to our end users. And so the reason why that's important is that by continually delivering, we're always going to be giving value to our end users. So nowadays that's super important, right? Because the business has to change quickly. It has to respond rapidly. And if it takes you 2 weeks to deploy something that one of your business stakeholders wanted to get deployed, then you've got a problem. And those are the type of companies that eventually get have to go out of business because they can't keep up with everybody else. So that's why this has become so important in today's climate. And one of the things that we've done, so let me give you a little background how I got into this. I was brought into a couple of Sitecore projects at Perficient, and I was brought in mainly as somebody who could help the teams automate their deployments. That was the initial charter that I was helping with. And then it turned out that on a couple of the projects, they said, well, since you're doing that, can you just go ahead and make sure the infrastructure is built out? And so I started doing both. And then the first couple of projects I was doing, they were on premises. And then we had a couple of cool projects where we got to host everything. And we were responsible for hosting the Sitecore site that we're building, and so we did it all on Azure, and that was where things really took off. And so then that's when we started learning about the Azure ARM templates and how to use those, how to use the ARM template project or the deployment projects in Visual Studio. And so it was cool because I was able to combine the deployment of code and the infrastructure, because we turned the infrastructure into code, which is that's the ultimate. And the reason why that's so important is because you can guarantee that your environment is going to be the same every time. So in every different environment, so there's a couple key things that are pretty cool with that. So you're guaranteeing that you're going to have the same setup in every environment, except for the things that change, like database connection strings and that kind of stuff. The other thing that's really helpful is that let's say for example you come up with a little bit more complicated Sitecore environment, maybe where you have a load balanced 2 CD servers or something like that. They're load balanced, and you have maybe some network security requirements. You make sure that nobody can get into those servers, and the CM servers, lockdown, that type of stuff. So you can define all that stuff in your template. And then the cool thing is that if you make a template really generic, you can reuse it on other projects. And so that's kind of what we've done. We've built some pretty generic templates. We've kind of labeled them we'll have a development template where everything is on everything that you need for Sitecore is on the one box. So it's a CM and CD. We call that our development template. And then we might have another one that might be CM only, or CM or a CD, load balance, a single CM with 2 load balance CDs, that type of stuff. So that we were able to reuse a lot of the code that we did in the ARM templates, and we were able to do some pretty complicated stuff, and then save a ton of time because we parameterized them so much, we made them fairly generic. And so when if we were switching to a different customer or something, all we really had to do was just change what the parameters were that were being fed into it. And we took a process that used to take just to spin up an environment, for example, like QA or UAT or something like that. That used to take a couple of weeks. We were able to do something like that in 10 minutes. And then ultimately, what we were able to do is we would start with no environment, and we had all of our source code, and we went into VSTS, pressed the deploy button, and everything was all the infrastructure was created, all the servers and the code was deployed, and we had an operating website. So that was the ultimate nirvana. So I'm going to go ahead and just show what that looks like right now. And I'm going to share Visual Studio real quick. Okay, I'll wait a few seconds for the screen to show up. Okay, hopefully it's there now. So I'm going to show you what these ARM templates look like. So there's also a few other things besides ARM templates also that I'm going to get into. I'll just show you the one that we're using for the developer machine. You can see here how you have in Visual Studio we have the JSON outline. So here's our parameter section. I'm going to minimize that. And then here's all the resources. And so here's what we're creating. We have to have a storage account. That's where the VM files live. And then we were basically creating everything. We have an IP address resource. We even have the network security group. We have our own virtual network, and even down to the the network interface card on the machine. So all that stuff, and you don't have to memorize how to do this. If you use one of the templates in Visual Studio, it just says, I want to create a VM ARM template, then it'll create all this for you. It doesn't do it very nicely. When I say that, I mean it's got a lot of things that are hard-coded into it. So I've kind of gone through and made it given these nice descriptions here so you can see graphically what your ARM template is really doing, and pulled a ton of stuff out into parameters and variables. So obviously we want to pass in the username and password to the VM machine, that type of stuff. Obviously, all the stuff for the database, the database server login and password, those are all parameterized. So if you're a developer, then if you've done stuff with dependency injection before, you kind of understand why that's important. You want to, with dependency injection, you want to push your dependencies out as far as you can. And so the same thing applies with our build. And George is going to cover this later too, but we can, by parameterizing out, the username and password, that type of stuff, we can even go as far as making those build variables in our build environment. And so that's where we actually inject them. And so with the different environments, if you wanted to have different accounts, you could do that stuff and your template could stay the same. So that's why it's important to use these parameters. And then variables that's your way of doing things that use the parameters to build and shape the data the way you need it. So for example, storage account name. I'm just using some of the built-in functions here inside of the ARM templates to create a unique storage account name. And so I have a parameter for the client name and the environment name, and I append the word storage to it, and I know that's always going to be unique. And that's that way, and since it's parameterized, I'm pretty much guaranteed I can reuse this template, and every time I reuse it, I'll have a unique storage name. So anyway, that's how that works. Now the other part that's you're probably wondering is, okay, cool, we can provision a server. That's great. Provision a server and a network in Azure. Okay, awesome. Now what about when we provision the server? There's nothing on it. It's just a regular Windows server. So what we have to do then is we need to put IIS on there. We got to make sure the right version of .NET is on there. And then obviously we got to get Sitecore installed and configured. And so that's where the cool thing in ARM templates is we can use desired state configuration, DSC, which is a special PowerShell scripts that the ARM templates have a special extension for that. And so here is this right here, so here's the display name. This is my DSC extension, and then it has so I have so you can see here the name is even put out to a variable, but then here's my custom extension right here, and you can see what this is calling out to do some remote scripting on the actual server. So it actually runs a Sitecore install PowerShell script. So, but this is the extension that gets called. So this is the extension that's actually wired up into the ARM template. And then there's a few settings that you have to tell it. So you're saying, okay, this is PowerShell, this is the DSC extension, tell it the version, and then here's where you're saying, okay, this is where the artifacts are going to be. It's going to be DSP. So this this extension is going to get zipped up into a file called vst.zip. And so the ARM template has to look for it there. So that the ARM template, once this gets provisioned, this is actually going to get copied to your target server, and then the ARM template is going to go to that server and actually execute this PowerShell script here. So it's going to be executed remotely from the ARM template. And then you can see here's the function that it's going to call, which I put into a variable, but the function that it calls, oh, I'm sorry, here's my wrong one. This is the DSC, and here's the function right here. This is main. It's going to call that. So this is my DSC. The DSC, like I said, pretty standard. It's just making sure that all the correct Windows features are there, like IIS and ASP.NET. And then in our case, for what we were using, we needed .NET 4.6 installed. So I actually put in a custom script here to install. It goes out and downloads and installs .NET. Now, something that is kind of cool that you can do in the ARM templates is, let me go back to the JSON outline. And notice how I have the Sitecore installation and configuration extension. So we have the IIS one and then the Sitecore one. So I'm sorry. So this is the Sitecore custom extension. So that's the one that's being called right here, what I have highlighted here. And you can see for this one in the ARM template, I'm telling the ARM template, here's all you see all these file URIs. These are all the files that are needed for that custom extension to work. So it uses azcopy.exe and a few others because it has to do some things. One of the things that my Sitecore custom extension does, it has to download the install to install Sitecore. So we have the Sitecore install package as a zip file, and we store it in an external, another storage container in Azure, and then we download from that storage container, and then we're telling it, these are the tools that we need here to be able to do that download using azcopy. And then we do a couple other things. We have to enable WinRM so we can execute remote scripts on it. And then here's where we're saying, okay, we're going to install, here's a config file that we need for our Sitecore PowerShell script. Here's our Sitecore PowerShell script that we want to run. And then here's the Sitecore custom extension file name. So all that stuff, by setting this, it's going to get pushed out to the artifacts directory, and then it can be used from the ARM template. Okay, so let's go back real quick. So the other thing I want to point out that's pretty cool here is, a couple of things. I'm going to get to the database in a second, but the thing that I thought was interesting is that you can do in the ARM template is you can set up dependencies. So you see this depends on node right here. And obviously we can't run we're not going to run anything unless we're not going to run an extension if we don't have a VM. So this is saying, hey, don't do anything until the VM's created. And so when the ARM templates run, the way they get processed in Azure is that everything starts, getting created in parallel, so it can be done as quickly as possible. But we have dependencies, and so we're saying, hey, don't try running this until this thing has signaled that it's completed. And then we also say, so this. Let's go back here again. So we're talking about the Sitecore installation, right? So for Sitecore installation, obviously we need a VM, and also we can't do anything until the DSD is done, right? The desired state configuration script that's ensuring that, .NET and ASP.NET and IIS and all that stuff is on the server. So we need to wait for that too. So here's where we specify that. We're specifying the same way we named it. We're saying, okay, wait for this extension, and has a variable name, the DSC configuration name. So if we go up here, go to variables, and you'll see in variables, you'll see a DSC configuration name. And let's see, oh, it's not in alphabetic order. Okay, there it is, DSC configuration name. So you can see right here, okay, in this case, it's just a constant, but there could have been something going on there where we're concatenating something together. So anyway, I thought that was pretty cool that we were able to get all that stuff going. So we have, we're able to start with a server from scratch, get it ready to install Sitecore, and then we actually have a PowerShell script that installs Sitecore, and it makes all the correct changes to the its configuration file, so it points to all the right databases. So the other big thing that you're probably wondering about is what about the Sitecore databases? And so we're provisioning the database server, but not the databases yet. That's a separate step. So we provision the database server. And remember before I talked about that dependency injection pattern? We're doing that here. I guess we can call it the deployment dependency injection, or the ARM template deployment dependency injection via parameters. So we have parameters. So if we look at let's look at the definition of the database server. That should be highlighted in my JSON when I click here, and it is. So here's my definition of my SQL server. This isn't the database, this is just the server, the database server. And so you can see here I have properties for admin login, admin password, and those are parameterized. So like I was saying before, those can be passed in all the way from the build. And then a few other admin things here like firewall rules. In this case, it was a dev machine, so we're just letting all IP addresses in just for the heck of it. You see there's a note there, just for demo purposes. But you can specify, who can get into the firewall to access the database. So that's the big thing right there, is getting the database provisioned, the database server, and then we have a separate ARM template to do the databases. And the way that works is Sitecore's provided some, they've provided several backpack files for all the Sitecore databases, and then you can create your own backpack files as well. I think we created a couple of our own backpack files. So we store those backpack files, which are basically just backups of the database. We store those in an external Azure storage account, and then we use this to go ahead and import the databases. So you can see here, we are specifying the Sitecore database server again. It's pretty much exactly what we did before, but that's okay. It's not. You can run this thing over and over again, and it's not going to error out. It's just going to say, oh, it's already there, and it'll see if there's any updates that need to be done. It just does this. But you can see here, I have the core database, and then inside that there is an import. And so there's an import extension for databases, and so then I just do the import, and I import the, I have a dependency on the server, and then here I'm specifying where that backpack file lives. So there's the storage key for that Azure storage container, or the key type, so it's storage access key. Here's the actual key, which is a parameter, and then I build the storage URI right here. And then you can see here, it's the Sitecore _core.backpack file. And put in the login and password to that database as well, and then self-import. And so then when your ARM template executes, it will start the import. One thing that George will show later, it's we are debating, we may decide to change this later to just do, instead of backpack, do DACpack. So that way, if you have changes in your database and stuff, it'll just run the differences. And we just didn't do that here. If you run this more than once, it will fail. But what we've done is we just went ahead and, if it failed, we just told the build to continue running because we knew after it was created first it would do that. But we're going to go back later and revise it to probably use DACpack so we can get like the actual like SQL differences and apply those every time we deploy.
Hey, Tim. Sorry to interrupt. I just want to make sure that we're allowing enough time to cover all the great information that we have. So maybe if we could move forward, and if there's still questions about this, we could come back to it at the end if we have time. Would that be okay?
That's perfect. Yeah, let me go ahead and stop sharing. And
awesome. Thank you.
Yeah, let me go ahead. I think we have a poll on the next slide. So I'll let you guys go ahead and fill this out, and then once that's finished, I'm going to turn it over to George. Okay, I'm going to go ahead and just get to the results. I don't know if we've had some people that went ahead and did it. Okay, I'm going to go ahead and turn it over to George. I've already done the demo. And, oops. Okay, there we go. Take it away, George.
Thanks, Tim. Thanks again for your time, everyone. So I wanted to cover a little bit more as far as more Sitecore-oriented things and how DevOps can benefit your organization, right? So first, these virtual machines that Tim just demonstrated, they're no longer the only way to host Sitecore applications in Azure. So as of a few months ago, with the release of Sitecore 8.2 Update 1, Sitecore also provides support for Azure App Services. So that's Azure's platform as a service offering. What's the difference between an app service and a virtual machine? So traditionally, in an on-premises hosting situation, you get what you have highlighted on the red box on the left, right? So you own the machines, you do all the maintenance, all the way down to the physical hardware level. So if memory goes out or hard drive goes out, that's on you to make sure that you have the proper fallbacks in order to keep your servers running correctly. So one of the motivations of moving to the cloud is to free up the resources, both technical and human, of having to do kind of tedious and routine maintenance on your servers. So with Sitecore, you have two options, and that's what's outlined in the blue. The first is the VMs that Tim was talking about. So that's labeled infrastructure as a service. And then as a platform as a service, we have Azure App Services. So you see with the virtual machines, you still have to manage everything from the OS up, so Windows updates and antivirus and all that good stuff. That's still on you and your organization. However, the hardware is managed by Microsoft or whichever cloud provider you choose. With platform services, this gets abstracted just another level deeper. Now even the operating system and everything is managed by Microsoft or your cloud provider, and you're only concerned about managing your application and your data. So these are the two options that Sitecore has provided now as part of Sitecore 8.2 Update 1. So talk about that in a little bit more detail. This new version of Sitecore on Azure, right, uses Azure Platform as a Service. So this infrastructure with Azure App Service, back to the ARM templates that Tim was talking about before, they operate under the same premise. You can also deploy these app services just like how you would deploy a virtual machine with those JSON templates. So you can configure your environment how you would like it and deploy those JSON ARM templates out and create app services or virtual machines. Sitecore has actually placed some sample ARM templates out on their GitHub repository, so you can download and use those immediately, or you can tweak them to your liking. So the benefits of using these Azure App Services actually extend beyond just mere server management. They also allow you to scale up and scale down very easily. So in Azure, there's a slider basically that you click and drag to set the number of instances that you want, and Azure in the background will automatically clone your application, and you can scale out your application as much as you need to. This can also be triggered by something automated, such as a resource load. So when memory gets high or when CPU usage gets high, Azure can automatically create more instances to distribute the load. So this is kind of best used with Sitecore's new consumption-based pricing, so that you can use as many servers as you want as far as a scaling out perspective, and then it bills you on a consumption basis. On the right here, we see sample Sitecore Azure App Service configuration. So this is actually the configuration that comes on that Sitecore GitHub site that's labeled XP. So you'll notice here, instead of any virtual machines, we have 4 Azure App Services, one for each Sitecore server role type. So there's one for content management, one for content delivery, one for processing, one for reporting. The reasoning for this is that by keeping them separate, you can scale them independently. So if you have a temporary heavy load or a seasonal load on your site, perhaps it's e-commerce or of some type, and you get a lot of heavy traffic right before the holidays, you can easily scale that up, and scale the content delivery servers specifically without having to scale your content management server up as well. So you can have 8 or 10 different content delivery servers, but keep that one content management server. Same with the processing server. As user load gets up, you probably want to scale that as well to handle the user load for XDB. With the SQL servers, there's 2 of them, and they follow a similar pattern. Again, the web database is in its own SQL server, so it could be scaled independently. Otherwise, the other servers the other database servers are in their own SQL server. Search is now handled in Azure App Service by Azure Search, so that's a search service provided by Azure. So by default, there's no more Lucene. Part of this is because, from a technical standpoint, Lucene needs a file system to run, and Azure App Service abstracts that away. For caching, it uses Azure's Redis cache, which is extremely quick. And there's no more Sitecore logs, so all logging is happening in Application Insights. In addition to logging, Application Insights also provides a number of other site metrics that are pretty useful. So you'll notice the note on the bottom that there's no there's no Sitecore supported XDB equivalent on Azure right now. So your alternatives for that would be to use either Sitecore's XDB cloud service, a virtual machine hosting your own MongoDB instance, or a hosted MongoDB service like MLab. Ooh. All right. So this is basically a diagram of that exact same configuration. So you'll see that visitors will come in and they'll hit the delivery servers. That could be multiple delivery servers and all the various services that are tied from a visitor's perspective. Authors come in from the content management side, and all the arrows pointing to all the services that it's going to access. And then you'll see on the right you have processing and reporting instances, and that's what crunches down all the XDB data that's in the collection database and pushes it to a reporting database. So this is very similar to how a typical virtual machine or server-based Sitecore topology would look like. Though instead of virtual machines, we're now looking at Azure App Services running those workloads. So this brings us to continuous integration and delivery. So this, to be clear, this is just one part of the greater DevOps world. This is probably the part that that gets the most attention, probably because it's the biggest. In the quote in the first slide that Tim shared, it talks about DevOps being a union of people, processes, and tools. Right. So this is just to get a real good sense of a good DevOps strategy. You have to have people to buy in. You have to have an established process, and you have to have the tools to run that process. And this is what brings us to continuous integration and delivery. So this is another quote from this guy named David Farley. It says, "There should be 2 tasks for a human being to perform to deploy software into a development, test, or production environment: to pick the version and environment and press the deploy button." So this is the holy grail. This is where you want to get to, right? To be able to, I want to deploy my code base here, click a button, and have that automatically build and deploy to your environment. So let's look first at continuous integration. What's continuous integration? Continuous integration is this practice of having frequent automated builds to an integration environment for the development team. So ideally, this is something that happens every time someone on a development team makes a change to code. So these changes are immediately built and pushed out to an environment. So what's the benefit of this? First, there's visibility to the entire development team. There are many developers might be working on this team and they're making changes, and these changes might affect each other. This gives instant feedback to developers to help resolve any conflicts. Additionally, this provides an opportunity for regular and frequent automated unit and integration testing, so that by the time it hits the next environment up for QA or staging, for instance, this results in less issues. So to have a successful continuous integration process, you really need to have a centralized code repository, automated build, automated tests. Right, so this practice of continuous integration could be used as part of a code review process. So for example, if you have code that you've committed into a repository, it has to pass a code review before it gets merged in. So and if it doesn't get merged in, it doesn't get built. So you can ensure that only code that's passed through a code review goes into an integration build so that you're not breaking builds all the time. So what is continuous delivery? Right? Often I think there's confusion about these phrases, continuous integration and continuous delivery. A lot of people assume it's the same thing. While continuous integration is more for an internal purpose, continuous delivery is more of an external, has more of an external purpose. Continuous delivery is a practice of frequent automated deployments to a production environment. So that sounds a little scary. But remember, because we have that continuous integration process from the previous slide, a lot more vetting has gone into a typical code base that has been built out and released before actually deploying to production. This doesn't mean that every single build has to be pushed out to production, but every build that gets pushed out could potentially go to production. So by automating this process, you can minimize the resources for a typical production deployment, and it can be done more often. And so back to the beginning of, the more often you do these production builds, the faster and more often you can provide value to your customers. So Martin Fowler, he's a big guy in the .NET world. He has a lot of books with dependency injection and whatnot. But he talks about continuous delivery a bit. So he has this quote. It says, "The key test is that a business sponsor could request the current development version of the software to be deployed into production at a moment's notice, and no one would bat an eyelid, let alone panic." Right, so more than likely that's not the situation in all our organizations now. If some stakeholders said, let's build a production right now, there would be a lot of consternation that would happen. But with an automated build process and release process, you can definitely get much closer to there. And just to give you an idea of, kind of the model pattern of what this continuous delivery looks like. Back in 2011, Amazon gave a presentation, and they basically said that they deployed their production environment on an average of every 11.6 seconds. And that's a deployment to about 10,000 servers simultaneously. So you would think that deploying to 11,000 servers every 11.5 seconds would increase more outages, but actually their results showed a completely different story, right? So they were able to reduce their outages by 75%, and they were able to reduce the time of their outages, the duration of their outages to about 90%. So actually, the percentage of software deployments actually causing an outage was only 0.001%. So that's extremely tiny. That's one out of every 100,000 deployments would cause an outage. So this is the kind of type of power and flexibility an automated continuous delivery cycle can help provide you. So let's move on. So move on to kind of a typical build and a release process. So this is a common build and release process, right? This is very generic. Basically, code is pulled from a code repository, it's built, and any necessary tasks are executed upon the built code. So these tasks could be, gulp tasks, or compiling CSS, or compiling JavaScript or TypeScript, anything that needs to happen for extra compilation from a non-server compilation perspective. This gets pushed through a round of automated testing. So unit tests are executed and run, and what comes out of this are build artifacts, right? So these build artifacts can vary anything from web deploy packages to zip files to NuGet packages. In a continuous integration situation, a release is kicked off immediately once these build artifacts are generated. So the build artifacts are then pushed into a release, and some environment-specific transforms are performed on these artifacts. And these are going to be parameters and such that are going to be specific to each environment. So we're talking connection strings and any other environment-specific parameters that might occur. So as part of that, it does the transforms and it deploys all the build artifacts into your dev environment for continuous integration. So now in continuous delivery, right, like a business user can say, hey, let's build a production, right? And you already have a build with a set of build artifacts out there, and it's a matter of taking that latest stable build and pushing it through the same release process. But for the production environment, it does the same set. It does its set of transforms with the same set of build artifacts and deploys to the production environment. By sharing the same set of build artifacts, we can assure that the code that's going into the production environment is the same code that's going into all of the environments. So here at Perficient, we use Microsoft's Visual Studio Team Services to run our projects and orchestrate our builds and deployments. So it's our preferred platform because it has really good integration with Visual Studio, with Azure, with Windows Server. Not everyone may be like us and are so Microsoft-centric as far as the technology stack goes. But Visual Studio Team Services can definitely handle that. It's very extensible in their connectors for non-Microsoft tooling. So things like Octopus Deploy, if you're using that internally right now. Also, you could push notifications to Slack. You could create work items in Jira. There's a lot of extensible things that go along with Visual Studio Team Services. And you'll see on the right some of the features of it. It's a full stack software lifecycle management tool. This includes everything from hosting a code repository to project management tools to builds and releases and managing test plans. In fact, this is something that all Visual Studio Team Services is Team Foundation Server in the cloud. So that's what we've been using. Let's move on. So talk about, we have a poll. So do you currently use or plan to use Microsoft Visual Studio Team Services? Yes, no, we do not and have no plans to. We don't currently, but we plan to, or we're not sure yet.
So, hey, George, while we're waiting for them to do the poll, I was thinking one other cool thing about VSTS is it has, for source control, a lot of times people think, I have to use, TFS source control, but it's actually like pluggable, right? So you can, it has built-in providers for GitHub, which is kind of, Microsoft uses that all the time, and then there's 10 other ones. There's all these different pluggable plugins and web and all kinds of stuff. So.
Yep. So it looks like a good portion of you are using Visual Studio Team Services, which is awesome. Probably the rest of you are using something else or maybe TFS. So let's move on. So Visual Studio, we talked about extensibility. They provide a marketplace. So additional vendors can actually add extensibility to Visual Studio Team Services. Let's talk about build definitions. So build definitions is basically this step process in order to build and compile your code to build those build artifacts. So I don't know how well you can see this, but this is a screenshot out of Visual Studio Team Services. So we begin with the code repository, and we compile the code, and out of this, what comes out of it are build artifacts. So these steps should look pretty familiar if you're in the development world. These are typically the steps that are taken as far as doing a development build on your local developer machine. A lot of these variables and such that Tim was talking about earlier, these can be defined as part of the build. You can store secure passwords in here. So if you need a secure password to pull your code down from a repository, that can be stored in here. And there's a lot of triggers that can happen as well. So these builds can be triggered by either code commits, they can be triggered by a schedule, or they can be manually kicked off. Also, if your build fails, it can automatically create a work item or a bug and assign it to the right person so that they could take care of whatever the issue is in order to cause the build to succeed again. Again, the result of a build like this would be deployable artifacts. In this case that we're talking about, the deployment artifacts are web deploy packages. Then release definitions. This is basically a similar thing, but for releases, it follows this similar stepwise process, but you'll notice on the left there's actually 4 boxes. Those 4 boxes correspond to the 4 environments that we have. So this is, in this situation, these are Azure virtual machine environments. So for Azure Dev, we have a virtual machine, for Azure QA, Azure Staging, Azure Production, and each one of these environments on the left, they could have a different amount of steps, a different set of steps in order to deploy to those environments. But the main point is that you are using the same set of build artifacts for each environment. So you always start with that set of build artifacts. It goes through the deployment process. This one specifically uses WinRM to deploy the web deploy packages, and what results is a full deployment to an environment. So tying back a little bit to what Tim was talking about earlier, with ARM templates, one of the things that you can do as part of your build and release process is to deploy an ARM template. So what does this mean? This means that you can actually, as part of your build and release process, tear down all your infrastructure and rebuild it, or update/upgrade your infrastructure as part of your release. So you can keep the ARM templates as part of your code repository, make some updates, and then deploy it again, and that'll update your infrastructure, whether that's app services or VMs. Or you can have it tear it all down to the studs and rebuild all your servers, use DSC, use everything to build your servers back up so you have a clean environment for each deploy. That might seem like overkill a little bit, but there's been a number of occasions that I personally have experienced where you get very production environment-specific issues with production that you can't seem to resolve because there's some lingering file out there or some configuration that's bad that got screwed up over the course of time. This last topic I wanted to cover was about blue-green deployments. So this is a very popular concept in the DevOps world. The idea with blue-green deployments is that you have 2 identical production environments, and this strategy is basically for a zero downtime deployment. So what happens is you have your one live environment. We'll say it's the one up top. That one's the current live environment. You have a secondary environment that's not publicly facing, and you wind up doing your production deployment on that second environment. The first environment is still live, still serving content, but the deployment is happening to the second environment. No one's looking at it. You can do your internal tests. You can warm up the servers. You can make sure all the caches are spun up, especially with Sitecore. There's a lot of caching. And then once everything looks good to go, as part of that, you can hit your traffic manager or load balancer and have it switch the DNS to point to the second server, effectively making that newly deployed server your live production server and taking down the other server. That now no longer live server, that server can be used for the next production environment, for the next production deployment, I'm sorry. So that environment can either be spun down if you're in a virtualized environment, save some money. You can stop those or take those down, or destroy it altogether if you have ARM templates and just spin a new one up when you're ready to do the next production deploy, or you can keep it up as a staging environment to do testing against. So with this, we can see we can, as long as you have an established process, and by using ARM templates, you can spin up an entire new environment. You can push a new build to an environment, and you can send the traffic to a new environment all with the push of a button. And that's really the goal of DevOps, is to be able to execute this entire process by selecting your environment and hitting a deploy button. That's it for me. Jane?
Awesome. Thanks so much, George and Tim. That was a lot of great information. So as a reminder, we are going to now open up the call to questions that have come in via the chat box during the session today. We've got a little under 10 minutes to address questions. So the first one is, how much effort is it transitioning from Azure Infrastructure as a Service to Azure Platform as a Service?
Yeah, that's a good question. I think part of it is related to how your current implementation is built out as. As far as the Sitecore platform goes, if you have a fresh instance deployed on an Azure VM or a fresh instance deployed on Azure App Services, there really is no major difference if you deploy your application on top of either of those, so it's pretty easy to migrate. There is one caveat though, even right now as of Sitecore 8.2 Update 2, there is still a number of Sitecore modules that are not supported. So web performance marketers, I think the publishing experience manager, there's a handful of modules that are still not fully supported. So if you do go to platform as a service with app services, it may not, and you're using those modules, that may not be a good idea, and you may want to stay on virtual machines for now.
Also the Lucene search won't work.
Right. But so Azure Search replaces that. So.
Yeah.
Great, thank you. Another question that's come in, can you mix Azure Platform as a Service with classic Sitecore Instant License model?
Yes, you can actually. The only limitation is that you're limited to the number of instances that you can spin up. So as far as scaling goes, you're limited from a licensing perspective. You're only limited to however many server licenses you have. So if you have 3 content delivery production server licenses, you can only scale up to 3 as far as the automatic scaling goes. So that's the only limitation. But with a consumption-based license, it's going to be unlimited instances and just strictly based on consumption. But that's also a good question for your Sitecore rep.
And I think we have time for one more here. Why would you want to build out your environments with code? Why not do it manually?
I'll take that one. Yeah, so that's a good question. That's kind of guarantees that you're always going to have a consistent environment. So you know exactly what's going to be there. So sometimes a lot of times what happens in environments where they're not using infrastructure as code, somebody will go in to production or even like a UAT environment and make a specific change on the server, like change the configuration file or something like that. And the developer may not be aware of it, and so a bug will come through, and they'll be like, oh, okay, well, I didn't make this configuration change. And then you have to go through the whole process of trying to figure out, what changed, what was the configuration change. And so by making it as code and putting it all in source control, everybody sees what all the configuration is, and nobody touches the server. The only way the server gets touched is when you do your automated deployment. So it just kind of makes the whole process is easier, especially when you have to track down a bug or something. You're guaranteed to have the exact configuration that's in source code. I see somebody had a question there about Chef. Yeah, you can. So it's not really a matter of TFS or Team Foundation TFVS. Just take that out of the equation. When we're talking about VSTS, think Application Lifecycle Management. So what source code repository you use, VSTS doesn't care. As far as using Chef, you can execute that type of you can execute any PowerShell script you want. So if you're going to execute a Chef script, you can do that as well. You can execute it remotely. So it's extremely flexible. You can pretty much do anything.
Awesome. Well, it looks like we've reached the top of the hour. If we were unable to get to your question, we will follow up with you shortly after the session. I just want to encourage you to follow the Perficient teams online as we have new information added daily. You can visit Perficient.com and click on the Insights tab for blogs, white papers, and upcoming webinars. We actually do have a white paper on this very topic that we encourage you to check out. We've also put up the Microsoft blog link, and you're welcome to reach out with us via Twitter if you have any questions. So we just want to thank you so much for joining us today, and we hope you can join us again next time. Thanks, everyone.